Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Clay is a fabulous author. Some of you might have read his book, Here Comes Everybody, or you might read things like the New York Times, Wired, the Wall Street Journal, Harvard Business Review. He often writes about collective action, internet society, and new ways that people interact online. And really, aside from all of his awesome honors, Clay is a great old friend of mine. If I ever have any questions to ask about, where's social going, or, what's happening around the world, that's really provocative and thought-provoking long-term in the future, the first person I always go to is Clay, and that's why we thought you guys might love hearing him talk to close out Faculty Summit. So with that, welcome Clay Shirky.
Thank you all. Thanks very much. I want to start with a story about the early days of the internet, which, even though the technology is considerably advanced from there, is still a story which I think a lot of resonance today. The internet, in something contiguous with its current form, came up in October of '69, and after the initial idea of packet switching and networking these computers together, the design documents called for the development of two applications: Telnet, which was remote access to computers, so that you could log into a computer held elsewhere and do work on that computer as if you owned it, as if you had it in your own environment. And FTP, File Transfer Protocol, which provided remote access to data. You could go get data off another computer and bring it locally. And the designers of ARPANET, as it was then called, got Telnet and FTP working, and they distributed it to the researchers who were attached to the network, and the result was pretty underwhelming, actually, that not much use of either of those applications. It turns out that although the logic of Telnet was other people can own computers so you don't have to, everybody actually wanted to own their own computer. People turned out to be much more interested in their own data than in remote data, and so on. And so it looked a little bit like an interesting experiment, but not much more than that. And then a third application appeared. This is not an application specified in the original design documents. It was not an application that anyone had directed the people working on ARPANET to build. It was, in fact, the port of a different application that had been written on a multi-user system at MIT called Multics. And Ray Tomlinson, the guy who ported it over in 1971, said, let's see how this thing we've got up at MIT called electronic mail does on ARPANET. So they ported email over in 1971. And within 3 months, email messages had become 75% of the backbone traffic across the entirety of the ARPANET. It turns out that remote access to machines and remote access to data paled in comparison in terms of people's desire to use it to remote access to other people. So hold that thought. This is a crowdsourced camera, right? Now, the idea of a camera is it captures a kind of an objective view of whatever it's pointing at. And the idea of crowdsourcing, in the parallel with outsourcing, is that it provides some sort of replicable way to generate material over and over again. But that's not really the way this camera works. This is a descriptive camera. It was done by Matt Richardson, who was at the Interactive Telecommunications program, just graduated, in fact. The descriptive camera takes a picture, as you would expect a camera to do, but instead of showing the user the picture, it uploads it to Mechanical Turk on Amazon. And it says, hey, for $1.25, we'll pay you $1.25 to describe this picture. People log in, they describe the picture, and then what the camera prints out is a little printer receipt printer of what was in the picture frame at the time you click the button. It takes between 3 and 6 minutes, and you get stuff like this. You get a building, and the caption reads, this is a faded picture of a dilapidated building. It seems to be run down and in the need of repairs, except repairs is spelled wrong. Repairs. So this is neither objective in the way we expect cameras to be or replicable in the way we expect crowdsourcing to be. And what I love about this is what the descriptive camera tells us is that whenever you get human beings involved, things get a little bit weird. That systems you expect to behave in a kind of normal or ordinary way start to get bent once you start applying human judgment. So, Facebook, famously the largest collection of human attention in any application on the planet, recently launched graph search, in which you can search for people based on their characteristics, right? And you can, of course, do set logic on graph search, which is show me the people with this characteristic and that characteristic. And so a guy named Tom Scott decided, he was one of the early people given access to graph search, he decided he would look through and see what some interesting graph searches you could do were. So here's one where people who like the virulently anti-gay group focus on the family, and also the actor Neil Patrick Harris, right? Here's a graph search of people who like, the violently anti-immigrant British political party, the English Defence League, and also like curry, right? These are not categories. These are not overlaps that make any sense. And it's tempting to say, whenever you get humans involved in your data, things go awry. It would be better to do without them, right? We would have a better stab at getting at something important or real if we could just ignore stuff like this. If we didn't have to worry about when people had conflicting or misapprehensions about what it was they were liking. But even that impulse can't be supported over the long haul, because at the same time that humans mess things up when we get them involved in the data, we're also essential to understanding a lot of what we care about in the world. So if you think about neighborhoods, where is a neighborhood? That is a category that matters to people. We know things about neighborhoods. We care about neighborhoods. We think of ourselves as coming from neighborhoods, going to neighborhoods, understanding what a neighborhood is like. And yet the concept neighborhood isn't a hard-edged fact. It's a consensus delusion around the maps of particular cities. So a guy named Andy Woodruff went around Boston just asking people, what are the borders of these neighborhoods? So here's the border of Allston. Here's the border of Brighton. Here's the borders of Chinatown. And in every one of these maps, as you can see, the dark blue areas, places where there's broad agreement. These are the streets, these are the blocks that are in this neighborhood. The teal part of the map is where there's a little bit better than 50-50 agreement, but not broad agreement. And then the light green stuff is the place where there is some agreement. 1 in 4 to 1 in 2 people say, this is in this neighborhood. And you can see how various the edges of the neighborhoods are when you go for the consensus view. In fact, remarkably, Chinatown, there's almost nothing that people agree on. Of the total area that Chinatown could occupy in Boston, right, the places that are the centrally agreed upon blocks are a tiny, tiny fraction of that. So you simultaneously can't do without neighborhoods as a way of thinking about cities. And you also can't generate any kind of hard-edged facts about them. You have to accept, right, that when we're gathering human information, it's not just that the data is messy. That makes it sound like it's something that can be easily cleaned up. It's that the mess is real, right? That we have to be dealing, when we're dealing with this kind of data, we have to be dealing with these kind of conflicting and overlapping edges. It doesn't just happen in Boston. If you look at the red line at the center of the graph here, that is what people in London report as the edges, the borders of the neighborhood called Shoreditch, which is a place where many of the city's startup internet businesses are. All of the other intersecting neighborhoods, however, overlap with Shoreditch fairly dramatically. So the amount of area that is Shoreditch and Shoreditch alone is, again, a tiny subset of the total area that people call Shoreditch that is shared with other of these overlapping neighborhoods, right? There's no way to get around these kinds of problems. Kate Crawford, who was a researcher at the Northeast R&D lab, Microsoft Nerd, talks about big data. And one of the things that one of the messages she constantly emphasizes is that if you have access to a large data set, that's not a shortcut for having access to the truth. you still have to ask yourself the hard questions about how are we going to construe this data as being meaningful? How are we going to construe this data as being something valuable, something we can work with? And the message of all of these maps, and indeed all of the examples I'm putting up here, are that it's impossible to get human beings involved without also getting human beings involved. That once you do something, whether it's a descriptive camera or a map of London, right, you are bringing in exactly the kind of messiness that can't always be cleaned up or washed away. And you can take this even further. You can dispense with existing neighborhood names. This is a project called Livehood out of Carnegie Mellon, which says if people associate with one another and they hang out in places where the self-consistency of those patterns is constitutive of a neighborhood, we don't need neighborhood names. We don't need street borders. We'll just look at check-ins. And we'll cluster. We'll take Foursquare check-ins and we'll cluster this so that we can detect where the neighborhoods are naturally occurring. So this is a place where you've even reversed the order. You're not just using humans to try and detect the edges of existing neighborhood names. You're actually using human input to try and develop the idea of a neighborhood full stop. And those kinds of experiments are places where when you bring the people and the data together, you have to rethink what it is you know about stuff like maps, which seem like hard-edged, unambiguously labeled objects. But when you see the way people actually use the city, when people actually use the space, all that illusion of hard-edged, uniquely named entities starts to break down. So it's easy enough to say for something like a city, collection of neighborhoods, well, yes, that's always messy. Realtors, among other people, have an incentive to sort of change neighborhood names as they go along. But there are places where you can count on people just dealing in kind of hard-edged, clearly defined entities. And surprisingly, wherever you look, whenever humans are involved, places where that seems to be true, even in those environments, the human condition reappears. So this is a screenshot from the Bugzilla bug database for Firefox, for the web browser Firefox. And this is bug number 330884. And this is just a regular bug reporting site. People come in and say, my software crashed under these circumstances, and the software engineers come in and say, either we've seen this bug and we fixed it or whatever. Bug 330884 was unusual because it began this way. So this user and her then fiance used the same Windows computer. And one day when she was using Firefox and telling it to ignore saving the login password for a particular site, it showed her all the rest of the sites for which the user had opted out of saving the password. Sites like JDate and Match.com and on down the list. And then she says, so this is the bug report on Bugzilla. And the Firefox engineers come in, they say, actually, this is not a Firefox bug. This is you guys not understanding how Windows worked. Really, it depends on the conditions under which this software was installed. And then the engineer goes on to say, so once you get used to the idea that even bug reporting databases can be sources of relationship advice, right? The idea that we can separate the messy human world and the clean world of managing data starts to break down, right? And that's really something that we're seeing over and over and over again, particularly in the current excitement about big data, machine learning. the idea that you can take a very large data set and glean information from it in a way that is relatively pure is exciting. And where it works, it's great. I don't mean that it never works, right? Anyone who's seen the amazing wind visualization recognizes that you're seeing something that's generated by relatively neutral objects, not completely neutral, but relatively neutral objects, and then being visualized in a way that is would be seen for almost anyone making that same visualization. But in cases like this, where it seems like this is software, right? We're dealing with something which is hard-edged bits and bytes running on a computer. And this kind of material shows up in that environment. You see how hard it is to separate the idea of clean data and messy human life. And how much, when humans get involved, they make us reconsider what we think we know about the world that we're operating in. This is a problem that a lot of industries suffer from, which is that our view of human behavior is often at odds with actual human behavior. Now, the medium that the industry that I've thought hardest about is media. And here we have a picture of people watching the Super Bowl on television. But this is a special kind of picture. This is a picture of people watching television as portrayed by people who make television. Right? This is a screenshot of people watching television on a sitcom. Right? Here is a picture of actual people watching the actual Super Bowl. Right? And once you see this, once you realize this is the difference between TV's view of us, of you and me, and how we behave, versus our actual behavior, you see how big this gap is. Right? The context in which almost all information that matters to the end user is produced, consumed, regurgitated, contextualized, operates in an environment in which we are all connected to one another, we are all paying attention to one another, and we are all altering our behavior as a result of those feedback loops. And those feedback loops makes the kind of cleanliness that's held out for a lot of current data projects not only difficult to get, but often not worthwhile. Because in fact, dealing with the overlap of data and the human world is a hard enough problem that it needs a different set of attempts. It needs a different set of approaches once you realize that the human mess can't be made simply to go away. One of the places where we can see the value of approaching generating value, one of the places where we can see the value in treating data as if it's something embedded in a human context, comes when we take large data sets and we expose them to the individuals, to the users, without knowing in advance what we're going to find. Right? Where actually sharing the data becomes not just the final gesture, here user, we made this for you, but actually becomes an opening gesture, an exploratory gesture to find out what the data means in the first place. So a few years ago, the Smithsonian tried this. They took several thousand of their photographs that had been copyright cleared. There was, in fact, no copyright on them because they were either produced by the government themselves or they had been produced prior to the current copyright deadline. And they just put them up on Flickr. They just put them up on the photo sharing service and let people tag them. Because the Smithsonian didn't know in advance what the users would make of these photos. So here are some of the tags they produced. This is in a sort of tag cloud format. The bigger the font, obviously the more important it is. Smithsonian Institution being the largest tag for the obvious reason. This is just the A's from that tag list. And rendered as if you had a very long, skinny browser, this is the entire list in that sort of same agate type they put on the back of the pill bottle. Right? This is a huge amount of user-generated data. And the interesting thing about this data wasn't the volume, but the variability. Right, back to the tag cloud. I want to call your attention to 3 items on this list: cyanotype, mustache, and steampunk. Cyanotype are users who care about the physical substrate of the photograph. They don't care about what's being represented. They don't care if it's a landscape or a portrait. They don't care if it's a picture of a horse or a house. They care about how the picture was made. These are historians of photography or people interested in the mechanisms of photography. That is a way of organizing these photographs that cuts across things having to do with content. It is an alternate it is an alternate organizational scheme that is able to exist in parallel with questions about content. Then mustache, right? There's a lot of pictures of people with mustaches. Facial hair, in the period that the Smithsonian has copyright cleared photos, facial hair was quite dramatic. But the Smithsonian, no matter how many people might be interested in going through and looking for pictures of people with interesting mustaches, the Smithsonian would never say to any of its catalogers, you can't leave work until you've cataloged every picture with a mustache in it, right? There is not enough professional attention that can be brought to bear on these photos to generate a list of photographs that would be of interest to people who only care about mustaches. In fact, the only group large enough to categorize everything is everybody. And then steampunk. Right? Steampunk is a form of science fiction which says, essentially, let's imagine that mid-20th century innovations happened in the mid-19th century instead. So we got Babbage's computer. We didn't get Turing's computer. If the Smithsonian would never pay people to generate the photos, to tag all the photos with mustaches, they certainly wouldn't do steampunk. And yet, why shouldn't people get value out of being able to identify photos that seem to line up with the steampunk aesthetic? What people are interested in is so much more various than could have been generated by the raw data set of these photos, that the value to the Smithsonian wasn't just getting cheap cataloging. In fact, the kind of cataloging the Smithsonian got out of Flickr was not compatible with their existing systems. The value to the Smithsonian was discovering what people cared about. And the metadata that came from exposing the data to a really broad cross-section of participants was the kind of thing that could never be generated in-house. And when you see that happen, you see how wide the range of uses can be. So one of the pictures they put up, they had a bunch of pictures of fish. So they put up a picture of a pudding wife wrasse. And the first comment on the pudding wife wrasse photo was, now your photo has been uploaded. The second comment was by someone who called himself the fishiologist. And he said, this is a great picture of a pudding wife wrasse. We have a whole database for people who study fish, for scientists who study fish. We're going to use your photo. Right? The Smithsonian didn't even know that database existed. They didn't have to. Having exposed the data, right, they got this use for free. So the conditions of data don't just include how big is it, right, how clean is it, but also how open is it? How available is it for people creating new kinds of value that the hosting institution couldn't predict? And then just under the fishiologist post about having posted this photo to Fishbase, comes a fabric designer and said, hey, I love this, I put it on a purse. Right? And it's really tempting to go through and say, well, the fishiologist with the Fishbase, like that's serious scientific work, but this thing with the purse is really silly. But there's no way to separate serious and silly if you're going to share like this. And in fact, one of the things we're seeing over and over again is the serious stuff and the silly stuff gets all mixed up together, and it's really difficult to separate, at least in the early days, while we're still getting used to this new medium. Now, it's tempting to think of that as being a function of the internet, right? Well, of course, you get all this lolcats and the board at work network and so forth. But in fact, this overlap of serious and silly in the same medium, this always happens. And I don't mean it always happens when you put up pictures of fish. I mean it always happens with media, full stop. It didn't take long after the printing press was invented before the first erotic novel started to be produced. Right? It did not take long after the printing press was invented before someone with a commercial incentive to sell books said to themselves, hey, you know what I bet people would pay for? Right? It took another 150 years for people to even think of the scientific journal. Right? So we are used to the idea that the printing press, the sacred printing press, right, the source and sink of the Western canonical tradition, is a very serious thing. But in fact, it isn't, and it never was. It was serious and silly all mixed up together. Right? And attempts now to say, well, these uses are serious and those uses are silly, in addition to just being hard to do as long as humans are involved, actually lead us to under-optimize for the value we would get out of seeing how people react to this data when we share it. And the consequences of that can be really enormous. This is a slice of the genetic sequence for the sudden acute respiratory syndrome, SARS. And when SARS broke out in the middle of last decade, there was a push to sequence it, right? To figure out what the genetic sequence was so that a vaccine or some sort of response could be developed. And the people who had the most incentive, right, to deal with the SARS epidemic were the Chinese. They had the earliest cases, they had the most cases, they had the most samples, therefore. They also have brilliant biologists and computer scientists and no shortage of equipment to bring to bear on a genetic sequencing problem of enormous importance both to that country and to the world. And yet, the SARS sequence was generated by a little outfit just north of here in western Canada called the Genome Sciences Center. The Genome Sciences Center did not have as much money as the Chinese government. The Genome Sciences Center did not have as many scientists. They did not have as much compute power. How did a little shop like that beat the people who had the earliest examples of SARS, had the most incentive to solve it, and had all of the resources needed? This started to be discussed as China's Mischance, because they were at the forefront of suffering from SARS, but not at the forefront of solving. And a few months after the SARS virus was sequenced, a clue as to what happened appeared in something called the Yale Global Journal, in which one of the scientists in Beijing who had worked on the SARS problem issued a blistering critique of their performance during the SARS epidemic. And he said the problem wasn't lack of samples. The problem wasn't lack of compute power. The problem wasn't lack of scientific muscle. The problem was that no one was allowed to share. That every time two institutions wanted to share something, we had to get permission. Every time we wanted to move a sample, we had to get permission. Every time we wanted to combine resources, we had to get permission. Genome Sciences Center beat the Chinese government because the resource GSC had most at its disposal was the ability to share. They could ask questions, they could answer questions, they could trade subsequences with other researchers. They could check things in and out of open databases. Even the institutional framing around big data is coming under some pressure or some reconsideration. It's not as if, oh, we used to have small data and now we have big data and we'll just deal with it the same way. In fact, one of the things we're seeing around organizations dealing with very large, very important data sets is if they can't share, they're actually stymied from working with the thing that matters most. Right? And this is one of the things that I think is going to be the biggest struggle as we try to deal with all of the data that the sensors in our pockets and the cloud and all of the rest of it are producing, which is that the institutional structures we have had for dealing with data, which assumes that data is largely held in-house by one organization, are now coming under this kind of pressure. And there are places where we're seeing people rethink how we should be dealing with the institutional structures from first principle. So this is an example, essentially in parallel to the SARS example, but now something that worked. This is from Tim Gower's weblog. Gowers is a Fields Medal-winning mathematician who, back in 2009, had a very provocative blog post that said, is massively collaborative mathematics possible? Would it be possible to take on this most abstract of problems in the same way that a Wikipedia article is generated? And the post went on to observe, right, two critical things. Anybody anywhere who thought they had something to say about the problem could jump in. And you would say something even if you thought it might be wrong, but might be likely to spark someone else's ideas. Right? So this is, in a way, a response to Genome Sciences Center versus the Chinese government. This is a way of saying we're going to rethink the way we deal with even these very abstract problems around the collaborative network we can also assemble using these same tools. So they launched something called Polymath. And Polymath is a blog and a wiki, and it works basically the way that Gowers had proposed in his massively collaborative mathematics post. And they would put up problems, and they would number them. So here's Polymath 4, which is a prime number sieve. And they submitted this. They'd done enough work on it. They thought, well, we've made some progress. They submitted it to the journal. They worked in the way that Gowers had suggested, which is they just tossed out everything they thought might work and then hashed out the different strategies to use. And when they got somewhere, they submitted it to the Journal of Mathematics of Computation. And this was the reply from the Journal of Mathematics of Computation. The good news was, yes, the paper made significant project in the basic math of prime number finding. And then you can see the suggestions made by the journal editor to improve the paper. And I like proofreading as much as the next guy. But this is not actually adding to the mathematical content of the work. This is really just readying it for publication. And then my favorite comment, the paper does not say who the authors are. Right? As if, obviously, a piece of intellectual work must have an author because that's the way the universe is. But of course, it's not the way the universe is. And in fact, on the Polymath blog, they go through, they say, yeah, they accepted the paper, they wanted us to get rid of the extra is. Now we have to make up a pretend list of authors. Right, to satisfy the journal publishing process. The one thing they couldn't say was, you're not clear who the authors of this paper are because it's not actually clear who the authors of this paper are. We've changed the process enough that traditional journals won't recognize it. So think how much the journal has changed from Philosophical Transactions, which I had up on the screen a little while ago, to now. Scientific journals used to be ways of increasing the radius and the speed at which scientific information would spread. Now they're ways of decreasing the radius and the speed, right? And they're principally there as stamps that appear after all the work has been done because, of course, since all the work was done in public, most of the relevant mathematicians are already aware of the result. Right? This is not, in fact, disseminating these results. It's just giving you a place to lodge a citation. The Journal of the Mathematics of Computation may as well be renamed the Journal of Ike and has tenure. Right? Because its function has become essentially validating at the end of the process. So when I say the institutional framing around data, right, is coming under pressure, Gowers and the Polymath project is what I mean. Right? There are alternate ways of dealing with this profusion of data and collaborative opportunities we have, which aren't just going to be our current practices updated. They're actually going to be fairly dramatic reimaginings of that. Here's another version of that same process, but now in a completely different field. This is Rap Genius. Rap Genius is there for annotating the lyrics of rap. So here are all the 50 Cent songs, and you can go and click on any one of these and say, when 50 Cent says this, he means that. Right? It's just a way of adding a sort of explanatory layer at the outside, essentially attached to these lyrics. But early on in the history of Rap Genius, people realized it says rap lyrics on the front door, but actually this is just a generic tool for annotating text. So they put up the Mayflower Compact, and they started annotating that instead. Right? And then somebody put up Barack Obama's 2013 inaugural speech, and then they annotated that. And Rap Genius, in turn, looked at this and said, these people are putting this existing tool into service in a new way, right? And we're going to respond. And so they've launched News Genius. And here's a page from News Genius. It's an interview with a 12-year-old boy who'd recently turned out in the streets of Cairo in the aftermath of the June 30th protest. And those yellow lines there are annotated parts of his speech, what he was saying to the camera. And then when you click on one of those links, you don't just get the annotation, you can also get additional photos. So Rap Genius has now decided to learn from its own users, right, and to develop a product that is much more about journalism than it is just about annotation. And this is what I mean about serious and silly. Whatever you think of 50 Cent's lyrical chops, right, the ability to learn from the users that there are other uses of this service and to change that service, to take advantage of that, that's the kind of thing that we're going to be seeing a lot more of. Right? The idea of data as a relatively pure thing that can be taken out of the human sphere, appealing as that is, and when that happens, as nice as it is increasingly running into the fact that when you get humans involved, you get mess like this. And instead of trying to contain the mess, when you try to learn from the mess, when you try to figure out what it is people are trying to do with a tool and change the tool accordingly, you can actually generate whole new categories of applications, as Rap Genius has done. So, back to the DARPA story I told at the beginning. It turned out, in the earliest days of the internet, that we had grossly overestimated, and when I say we, I just mean people who care about networks. I was not there at the time. But people had grossly overestimated the value of connecting to machines and the value of connecting to data relative to the value of connecting to other human beings. One of the things that we see over and over again whenever things are aggregated, whenever things are networked, is that for any given user, very often the most valuable thing at the other end of the wire is not the CPU or the disk, it's the other user. Right? And every place that we're seeing these networks expand, we're seeing these kinds of surprises from human adaptation around this data. So I'll put up one last example, and this is something that I showed my students. I taught the class for the Design Expo from ITP, from the Interactive Telecommunications Program. And in this class, this is one of the interfaces I showed because I think its message around what we're wrestling with and the overlap of many new data sources and human use is really interesting. This is Richard Pope's bicycle barometer. And it is a small wireless device that has, as you can see, two icons on it, a bicycle and the symbol for the London Underground, the London Tube. And he takes weather data on one side, which is obviously an enormous collection of available sources of weather data. And he takes information from Transport for London about whether the tubes are running on time, whether there's construction at his station. And he takes all of that data and he crunches it down into a single two-valued system. Should I take the subway today or should I take my bike? Right? And depending on the weather and the condition of the tube, the barometer will simply move in one direction or the other. And what I love about this is that weather data on one side and civic data around transport on the other are two of the most highly worked over sources of data. And the value that people have tried to create by creating new interfaces of that data is extraordinary. And yet, what Pope is pointing out is that no matter how much data you have, no matter how much compute power you can throw at it, often these things come down to a single human being having to make a simple decision. Right? The amount of data in each of those categories, weather data and transit data, could go up by an order of magnitude and the interface would not have to change. Because every morning he's going to have to make a choice. Do I take my bike or do I ride the subway? Right? And this interface, I think, reminds us that whenever you get humans involved in the equation, right, it's going to change how you're dealing with the data, how you're dealing with its creation, how you're dealing with its context, how you're dealing with its presentation. Right? And getting that right is going to be a big part of the challenge as the data of the world explodes around us. Remembering that the data is changing much faster than human nature and bringing those two forces into some kind of equilibrium becomes the design challenge of the next decade. Thank you very much. Thank you, and I think Tony's coming up.
You want to take some questions?
Yeah, if there are any questions. Oh. Oh, yes, in the back.
So I appreciate your point about the value of collaboration in science and getting different people to contribute. And I also take your point about how publishing journal papers is maybe in contradiction with that. But on the other hand, faculty members and researchers it's kind of a fitness signaling, right? You need to signal your fitness in some way. And if you can't do that and you're collaborating constantly, then how do people know what your fitness is?
I'm not suggesting you don't. Excuse me. I'm not suggesting you don't need a fitness signal. In fact, that's exactly right. I think that the decay of the journal function from being actually informing the relevant community what the current science is to just being a fitness signal is a problem. And one of the things we're seeing in the programming community is the fitness signals are moving to the places that are hard to fake. Like, what does your GitHub repository look like if you were showing up as a programmer? I think the best thing for the sciences would be if the fitness signal became tied more closely to the actual work rather than to the downstream validation by the journals. Because, in fact, being able to assemble the relevant community and have the conversation is what fitness is. I mean, advancing the scientific conversation through those kinds of contributions is closer to being a real fitness signal. One of the related stories of the Tim Gowers thing is when Dick Lipton, who runs the P does not equal NP weblog, the famously most important problem in computer science. A couple years ago, Vinay Dialalikar from I don't know if I'm pointing in the right direction, but HP Labs, whichever way the coast runs down at HP Labs, popped up and said, "I've proved it. P does not equal NP." And Lipton brings the paper onto his blog, and in 8 days, in the comments on that blog, they hash out the paper. And basically the verdict comes back. This is interesting, but it's got these two fatal flaws, and Dialalikar is back working on it. We don't know what the result will be. But that's the science. That's the fitness, is the actual people doing the actual work. And it would be better if either journals hewed more closely to that problem than a lot of the kind of publish 18 months after the fact stuff is, or in other cases, if academics and in particular tenure committees would update their sense of what the fitness signal is measuring in the first place. And both of those are hard things. I don't mean to suggest that this will happen overnight. But I think it is worth noting that the journal's original function of informing the relevant community has largely faded away, leaving them only with the fitness signal as their current rationale, which I think is not good for anybody. Was there a question over here?
My question is regarding the Smithsonian tagging.
Mm-hmm.
How would we know that there isn't just one or a handful of persons with fanatically large interests in mustaches and steampunk that, with a lot of time on their hand, that went and did all of this tagging that would bias the data? I mean, the tail end skewing the...
Yeah. So I'm virtually certain that is the case, and in fact, it is almost invariably a signal of large social systems that you get a power law distribution with the obsessives at the head end. If you do a social network map of Wikipedia, pick any two articles, see who co-edited them. Pick any two editors, see what articles they co-edited. You start to get these clusters of obsessives, right? So there's a group of guys, I'm assuming they're guys, there's a group of guys who edit all the articles on the U.S. highway system. So when you look at their user profiles, like I edited the article on U.S. Highway 28 and the article on U.S. Highway 31 and U.S., so, and they're the people near the head end of those distributions. So what I think is really interesting about what you said is that it biases the data. But I would say biases against what? Which is to say, if it's a reflection of the human condition that you have a large number of us that care a little bit about a lot of things, and then you have a handful of people who make the Star Trek articles really good, right? That those people they're part of the community. So I think our sense that that anything where human beings are behaving way off the bell curve is a bias is actually our misrepresentation of human nature rather than social life does not produce a lot of Gaussian distributions, right? It produces, a million power laws by the time you're done with breakfast. So I think the issue really becomes where are the places where having the mustache and steampunk obsessives harms anyone else? And if there are places where that's happening because you're doing some kind of ranked system and say, contributing tax dollars to it, then you worry about it. But if it's really just what kind of value can we get out of this if we give it to people to comb over and pick out the stuff that interests them, why shouldn't the obsessives be able to get their value out of the system as well? Again, this gets back to the point about the design of the systems not being neutral. You have to decide how much of a feedback loop you're providing. The tag clouds might end up biasing people to think steampunk is more popular than it is. But all of those design questions, they don't have any obvious neutral way to be answered, which is to say we always have to ask ourselves when the obsessives are there, and they're real people, and their energy is real energy, are we designing a system where their excitement about steampunk is harming anyone else or not? And I think to the degree that we can say, let them go. And if they're creating value for a small subset of users at zero cost to anybody else, that's actually, I think, a kind of thing we'd like to see from our sort of newly large and open data sets. But the problem that you point to comes up when we actually have feedback loops that cost other people something because of the obsessives doing their work. Oh, yes, ma'am.
Hi, I have a question. I should say hello. Thank you for your talk. Becky Grinter from Georgia Tech. So I've been really curious about the use of Amazon recommendation reviews as a political vehicle.
Yeah.
And so, and I was wondering, do you think that's another example in this genre about how when you introduce data, it, to humans, you get all of human existence?
Yes.
Or is there something unique else going on with this? And for those of you who don't know, two examples are if you take a look on Amazon at the shoes that Wendy Davis wore during her filibuster in Texas, a lot of the reviews are more pertinent to filibustering in Texas than to the shoes. And then also the reviews of any binders on Amazon completely went off the charts after Mitt Romney's phrase, binders of women. And they're really fascinating reading, so I'm very curious about your insights on this.
So this shirt, I don't know if you can see it, this is a 3-creeper moon. So it's the Minecraft, the default Minecraft monster, but it is a riff on 3 Wolf Moon, which was a T-shirt that was sent to the top of the Amazon charts because someone went in and wrote a funny review. I do think that that's exactly an example of this, and other things are plainly going on as well. But people's understanding of these systems, it's really interesting. They very often start, McLuhan said this first and best, the contents of the new medium are the old media, which always sounds gnomic and impossible to interpret until you read the paragraph right after where he explains exactly what he meant, which is what new scale does this introduce into life if there's a new medium coming along? And plainly, the new scale that the web is introducing is the scale of participation, the number of people who can say something in public. So an Amazon review is 2 things. It is essentially a kind of low-rent, amateurized version of a book review section in a newspaper, which is how it started out and how people started using it. And then people started realizing, hey, anything you type in here shows up on the page when I hit submit. Right? And then it's off to the races, and you get stuff like the binders full of women and Wendy Davis's shoes. One of my favorite, if you go and look at the Playmobil review, the reviews for the Playmobil figurines around the airport security station, spectacular, just well worth reading as a document, as essentially commentary on political commentary. And I think one of the most interesting things is that Amazon makes almost no attempt, modulo hate speech and a handful of edge cases, makes no real attempt to rein that stuff in. Amazon understands that actually letting users use that tool to say things to one another that are engaging and, frankly, bring people back to Amazon doesn't show up on the bottom line. The sales of binders themselves did not shoot through the roof. But the commentary around binders full of women did indeed put a political conversation directly into Amazon. Another place you can see this is any time a brand, I promise that's the only time I'll say that word today, decides that it's going to have a social media campaign. McDonald's famously started something with McD stories. And the number of people who wanted to comment on McDonald's either hiring practices or the healthfulness of its food realized this is just an open hashtag on Twitter. And it just exploded. Skittles made the same mistake about 6 months before. And I think the idea that we can separate people into consumers and citizens is a little bit the same thing. And I'm talking about if there's data over here and there's messy human life over there. People will come forward as citizens any place there's a public environment. And Amazon has become one of the interesting spots for that kind of public commentary. And there's no way to make that genie go back in the bottle without really destroying the thing that made it interesting in the first place. And I think Amazon is to be commended for not even trying. Right? The net is rife with stories like Friendster, basically people trying to make people stop using the system in kind of funny and playful ways. And that's turned out to be suboptimal relative to letting the playful stuff and the serious stuff go on side by side. Is there another? I thought I saw another hand up, but maybe not. All right. Well, thank you very much. Thank you. Thank you. Yeah, very good. Thank you.
Thanks very much, Clay. I particularly like the sharing data in SARS making a difference. And I think Microsoft needs to learn that humans are messy, and when you involve humans. I'd just like to comment on this wonderful poster. I didn't put it there, but that up the top there is a unitary operator acting on a quantum ket vector. So just to show the quantum mechanics is here. No, I really don't have to say anything other than to thank just a few people. There's a lot of people that need thanking, but Harold Javid, who was the general chair, Susan Dumais and Stuart Tansley with the program chairs, put together a great program. So I think we should thank them. And the other person I should mention is Roman Snitsar, who organised the Demo Fest, which was great fun. So can we give Roman a hand too? And there's a whole host of people, including the video, people behind and so on. But can I just pick out two people sitting in the front, Jen and Mariah, who really made everything work smoothly. And can we give them a round of applause, please, too? Well, that's it for another year, except one of the things that I insisted on was to have some beer after the event over the hall over there, and I'll join you for a drink, and the last bus to the hotel is at 7:30, so you got 2 hours. Okay, see you all there.